Europa. Jupiter has 95 known moons. Most of them are frozen, airless, completely unremarkable rocks that have been orbiting the solar system's largest planet for billions of years, without anything interesting happening on them. Europa looked like one of those at first. Then scientists started paying closer attention and realized it might be one of the most important objects in the entire solar system. Europa is covered in ice, a thick cracked shell of it stretching across the entire surface, carved up by lines and ridges that puzzled astronomers from the moment Voyager 2 flew past it in 1979. But underneath that frozen surface sits a global ocean of liquid salt water containing an estimated twice as much water as every ocean on Earth combined, not kept liquid by a sun, but by Jupiter's enormous gravitational pull constantly flexing and squeezing the moon's interior, generating enough heat to keep the water from freezing solid. The case for life on Europa is genuinely strong. The Hubble Space Telescope has detected plumes of water vapor erupting from the surface, meaning material from that subsurface ocean is being actively vented into space. The Galileo spacecraft detected a magnetic field consistent with a saltwater ocean beneath the ice, and scientists believe the ocean floor could have hydrothermal vents, the same environment where some of the most resilient life on Earth thrives in complete darkness with no sunlight whatsoever. If there is something living in Europa's ocean, it has been down there in complete isolation for potentially billions of years. No sunlight, no contact with the surface, just a dark saltwater ocean heated from below by Jupiter's gravity. Whatever evolved in those conditions would be unlike anything we have ever seen. NASA's Europa Clipper launched in 2024 and is currently on its way there. Whatever it finds is going to be one of the most significant moments in the history of space exploration. TRAPPIST-1e. In 2017, astronomers announced the discovery of 7 Earth-sized planets orbiting a single star 40 light-years away. 7. In one system, the internet lost its mind. Scientists could barely contain themselves, and for a brief moment, even people who do not normally care about space were paying attention. The star is called TRAPPIST-1, and out of its 7 planets, 3 of them sit in the habitable zone. TRAPPIST-1e is considered the best of the 3. It is almost identical in size to Earth and receives roughly 66% of the energy Earth gets from the sun. Climate models suggest that with a moderate atmosphere, surface temperatures on TRAPPIST-1e could sit close to Earth's average. For an alien world 40 light years away, that is remarkably comfortable sounding. Its year lasts just 6 Earth days though, which means it orbits its star extremely closely, and like most planets in this situation, it is likely tidally locked. One side permanently facing the star in constant heat, the other sitting in permanent frozen darkness. That sounds like a deal breaker, but scientists are not so sure. If TRAPPIST-1e has a thick enough atmosphere, heat could be redistributed from the day side to the night side efficiently enough to create a habitable band around the planet. Not ideal real estate by any means, but workable. Life is remarkably good at finding a way in conditions that seem impossible. What makes TRAPPIST-1e particularly exciting is that it is part of a system with 6 other planets, some of which are also habitable candidates. If life exists on one of them, the planets are close enough together that material ejected by asteroid impacts could theoretically travel between them. Life might not just exist in this system, it might have spread. 40 light years is too far for us to visit anytime soon, but it is close enough that if anyone over there is broadcasting signals, we should be able to pick them up. We have been listening, so far nothing, but we have not been listening for very long. Enceladus. Enceladus is one of Saturn's moons, and it is tiny, about 500 kilometers across, which in moon terms is basically a rounding error. It is the kind of object you would look at in a telescope and write off immediately. Cold, small, sitting in the outer solar system far from the sun's warmth. Nothing about it on the surface suggests it should be one of the most talked about objects in astrobiology, and yet here we are. In 2005, the Cassini spacecraft flew past Enceladus and detected something nobody was expecting. Massive plumes of water vapor erupting from the south pole, shooting material hundreds of kilometers into space. Not just water either. The plumes contained organic molecules, molecular hydrogen, carbon dioxide, and silica nanoparticles that could only have formed in hot water interacting with rock, all of it coming from a subsurface ocean sitting beneath the moon's icy crust. The presence of molecular hydrogen is particularly significant. On Earth, hydrogen produced by hot water reacting with rock at the ocean floor is a primary energy source for microbial life in hydrothermal vent communities. These are organisms that have never seen sunlight, have no connection to surface ecosystems, and thrive entirely on chemical energy from the rock below them. If that same process is happening on Enceladus, the ingredients for life are not just present, they are actively being produced. What makes Enceladus genuinely remarkable is that we do not even need to land on it to sample its ocean. The plumes are already doing that for us, shooting the contents of a subsurface ocean directly into space where a spacecraft can fly through and analyze them. Cassini did exactly that multiple times. A future mission with more advanced instruments could potentially detect signs of biological activity directly from those plumes without ever touching the surface. Titan. Titan is Saturn's largest moon, and it is genuinely bizarre. It has a thicker atmosphere than Earth. It has weather systems, wind, rain, rivers, lakes, and seas. It has a complete hydrological cycle where liquid falls from the sky, carves channels into the surface, and collects in large bodies that stretch for hundreds of kilometers. If you described it without mentioning the temperature, you might think someone was talking about Earth. The difference is that none of the liquid on Titan is water. It is methane and ethane. At minus 179 degrees Celsius, water is frozen solid as rock on Titan's surface. The lakes and seas that cover its polar regions are filled with liquid hydrocarbons, and the rain that falls from its orange haze of a sky is liquid methane drizzling down onto a landscape made of water ice as hard as granite. Everything we know about life is based on water as a solvent and carbon-based chemistry. Titan has the carbon-based chemistry in abundance, more organic molecules than anywhere else in the solar system outside of Earth, but the solvent is completely different. The question scientists have been seriously exploring is whether a completely different kind of life could exist using liquid methane instead of water. Not life as we know it, life as we have never imagined it, operating on completely different chemical principles, in an environment that would kill anything from Earth in seconds. The Cassini spacecraft spent years studying Titan and found evidence of complex organic chemistry happening in its atmosphere and on its surface. NASA's Dragonfly mission, a rotorcraft lander, is scheduled to arrive at Titan in the 2030s and will explore its surface directly, specifically looking for signs of prebiotic chemistry or anything more interesting. If life exists on Titan, it would be so different from anything we have ever encountered that we might not even recognize it as life when we find it, which is either the most exciting thing imaginable or deeply unsettling depending on how you think about it. Gliese 667. Most planets on this list orbit a single star. Gliese 667 orbits one star in a system that has 3 of them. Just imagine that for a second. 3 suns in the sky simultaneously. Depending on where you were standing on the surface and what time of day it was, you could have anywhere from 1 to 3 stars visible at once, each a different size and brightness. It would look like something out of a science fiction film, except it is real, and it is only 23 light years away. Gliese 667 is a super Earth sitting near the center of its star's habitable zone, which is about as good a position as a planet can ask for. It receives roughly 90% of the energy Earth gets from the sun, putting it in a very comfortable thermal range. In terms of energy from its star alone, it is one of the most favorably positioned habitable zone planets we have found. The complications come from the system itself. Having 3 stars introduces gravitational interactions and radiation sources that a single star system simply does not have. The long-term stability of the planet's orbit and atmosphere under those conditions is harder to model and harder to guarantee. One of the companion stars is also a red dwarf, which brings the familiar problem of stellar flares and radiation exposure back into the equation. That said, Gliese 667 remains one of the stronger habitability candidates based on its size, mass, and position in the habitable zone. If it has managed to hold on to a stable atmosphere over billions of years, despite the chaos of its 3-star system, the conditions for life could be genuinely excellent. And if there are aliens there, they have grown up under 3 suns. Whatever their version of astronomy looks like, it is considerably more complicated than ours. Mars. Mars is the obvious one. It has been the obvious one for so long that it almost feels boring to include it, except that the more we study it, the more the evidence keeps building in ways that are genuinely difficult to ignore. Today, Mars is a frozen desert, average surface temperature of minus 60 degrees Celsius, atmospheric pressure so low that liquid water cannot exist on the surface, and no magnetic field to protect anything living there from solar radiation. It is not a friendly place, but Mars has not always looked like this. Billions of years ago, Mars was a completely different world. It had a thicker atmosphere, a magnetic field, and liquid water flowing across its surface in rivers, lakes, and possibly even a shallow ocean covering its northern hemisphere. We know this because the evidence is still there. Ancient river valleys carved into the terrain, lakebed sediments, mineral deposits that only form in the presence of liquid water, and shoreline features that stretch for thousands of kilometers. Mars was once warm, wet, and potentially habitable for billions of years before something went wrong, and it lost its atmosphere. The question is not really whether life could have existed on early Mars. The conditions were right. The question is whether anything survived the transition. Because while the surface is now hostile, below it is a different story. In 2018, the Mars Express spacecraft detected what appeared to be a subterranean lake of liquid salt water beneath the South Polar ice cap. Further research has suggested there may be multiple such lakes. Salty, cold, sitting in darkness beneath kilometers of ice, but liquid. On Earth, microbial life has been found in environments almost identical to those conditions. If anything survived Mars's transformation by retreating underground, it could still be down there right now, completely unaware that the planet above it became uninhabitable billions of years ago. We have rovers on Mars right now actively looking. The answer, whatever it turns out to be, is probably closer than most people think. Kepler 442b. If you were designing a planet from scratch with the goal of making it as hospitable for life as possible, you would probably end up with something that looks a lot like Kepler 442b. It is roughly 1.3 times the size of Earth, sits comfortably in the middle of its star's habitable zone, and receives about 70% of the energy Earth gets from the sun. Those numbers are not just good, they are remarkably close to ideal. Kepler 442b sits about 1,206 light years away, which rules out any visit in the foreseeable future, or indeed any future that involves humans as we currently exist. But distance has never stopped astronomers from studying something interesting, and Kepler 442b is very interesting. The Earth Similarity Index, which rates how closely a planet matches Earth's conditions on a scale of 0 to 1, puts Kepler 442b at around 0.84. For context, Earth scores a 1.0. Nothing we have found scores higher than Kepler 442b. Its star is quieter and more stable than many of the red dwarfs that host other habitable candidates on this list, which significantly improves the chances of a stable atmosphere surviving over billions of years. A stable atmosphere means stable surface temperatures. Stable surface temperatures mean liquid water, and liquid water is where every origin of life story we have ever studied begins. The honest answer is that we do not know what is on Kepler 442b. We cannot see its surface, we cannot analyze its atmosphere in detail, and we cannot send anything there in any time frame that matters. What we can say is that on paper, out of every planet we have ever found, this one checks more boxes than almost anything else. If there is a planet out there right now with cities on it, oceans full of life, and creatures looking up at their night sky wondering if they are alone, Kepler 442b is one of the more credible candidates for where that might be happening. LHS 1140b. LHS 1140b does not have the same name recognition as some of the other planets on this list. It is not as famous as Mars or as hyped as the TRAPPIST-1 system, but among astronomers who study habitability seriously, it has been quietly building a reputation as one of the most promising candidates we have ever found. And the more data comes in, the stronger that case gets. It is a rocky super-Earth about 41 light years away, roughly 1.4 times the size of Earth, orbiting comfortably in the middle of its star's habitable zone. What immediately sets it apart from most other habitable zone candidates is its host star. Most red dwarfs are volatile, constantly blasting out flares and radiation that could strip away a planet's atmosphere over billions of years. LHS 1140 star is unusually quiet for a red dwarf. It produces significantly fewer intense flares than most, which means a stable atmosphere on LHS 1140b is not just possible but genuinely plausible. That matters enormously. A stable atmosphere is the difference between a frozen rock and a world with liquid water, weather systems, and the conditions necessary for life to get started. LHS 1140b receives about 43% of Earth's solar energy, which makes it cold but not impossibly so. With the right atmospheric composition, the surface could support liquid water, and some models have proposed it could even be covered by a large ocean. In 2023, the James Webb Space Telescope began actively studying LHS 1140b, narrowing down its atmospheric properties with the most powerful observatory ever built. Early results have been promising enough that it has moved to the top of many astronomers' lists of planets worth pointing telescopes at. It is cold, distant, and orbits a dim red star that most people have never heard of. But right now, it might be the single best candidate we have for a planet with life on it somewhere beyond our solar system. We just need the data to catch up with the suspicion. Thanks for watching. Make sure you subscribe for more videos like this one.